Alright guys, so now we're going to continue on with our triangles, but go ahead, check what you got for B and C here. So you should have gotten 30 degrees for B and then 60 degrees for C. Feel free to pause this video, check your work, see if you got anything different. But right now what we're going to do is we're going to move on to this guy, the triangle inequality conjecture. So this is a lovely mathematical term thingy that helps us to be able to look at triangles and be able to see if triangles are possible. So basically what this is if you add any two side lengths, so basically if you add the length of any two sides of a triangle, the sum, or basically the result from adding those two sides, needs to be greater than the length of the remaining side. Sorry, slow writer. I'm probably getting all my tapping from my pencil. Sorry about that. Okay? So again, triangle inequality conjecture, if you add any two side lengths, the sum needs to be greater than the length of the remaining sides. So let's look at this triangle here, and arbitrarily let's call it, I don't know. No, let's just stick with our letters. So if we call this A, B, and C. So those are the length of those sides. So what the triangle inequality conjecture is saying is if we take side A and add it to B, that result needs to be greater than C. Or if we take A and add C, that result needs to be greater than B. And then lastly, if we take B and add C, then that result needs to be greater than A. So again, if we take any two sides, like we did A and B, B and C, so on, those need to add up to be greater than the other side. So this is going to help us to see whether, if we're given some side lengths, whether they could possibly be that, be the measures of lengths of a triangle. So we're going to use that in 3 here. So 3 is asking us, state whether the given 3 numbers could be measures of the sides of a triangle. So we just use our triangle inequality conjecture. Let's check these. So if we just call like 4A, 10B, and 12C. So if we just take 4 plus 10, that's equal to 14, and that's greater than 12. So that works. If we take 4 plus 12, that's equal to 16, and that's greater than 10. So basically I took colors. I took A and then B, and those had to be greater than, not B there, than C. And then I took A and then C, and those turned out to be greater than B. And let's check this last one. If I take 10 or B plus 12, that's equal to 22. And that is definitely greater than 4, which is our A. So again, 10 was B, 12 was C, and 4 was A. So again, those added all together to work to be so that those two sides added together. So basically, if we look at any of these examples and the sides don't add up to be greater than the third, then that doesn't work. So let's just do another example. Let's call 12A, 22B, and 8C. So if we take A plus B, that needs to be greater than C. So 12 plus 22, that's equal to 34. And that's greater than C, which is 8. Awesome. So now let's look at, that's our first one to check. 2, if we do B plus C, that needs to be greater than A. So we take 22, add 8, which is equal to 30. And that's greater than our A, which is 12. Awesome. Now last one we need to check 3. So we need A plus C. Did this a little out of order. That's okay. You can check them in any order. So A plus C needs to be greater than B. So we take 12 plus 8. That's equal to 20. But that needs to be greater than 22. Wait. That doesn't work. Because 20 is not greater than 22. So that doesn't work. So this one would be no. That wouldn't be possible measures because of this last one right here. This first one would be a yes, because all of them work. We need to check all of them to make sure it works. So there are a couple examples for you guys. Go ahead and check those last 4, and we'll be back.